Glenn has a total of $11,600 invested in 3 accounts: a savings account paying 6% interest, a stock paying 8%, and a mutual fund paying 10%. The annual interest from the stock and mutual fund is twice that from the savings account, and the mutual fund returned $120 more than the stock. How much did Glenn invest in each account? So to find our variables, we took the 3 things that were different in the equation and made them x, y, and z. So the savings was x, the stock was y, and the mutual fund was z. Then we set up the equations due to the different percentages and the amount of money to make our 3 beginning equations. So for the first one, since we have a total of $11,600, we have x plus y plus z equals 11,600. Then it mentioned that the mutual fund is 120 more than twice of the savings. We did 2x equals y plus z. Then it talked about, since it talked about the $120, we did z equals y plus 120. After that, we took the first and third equation and used substitution to find our first new equation. So then we got x plus y plus 120 equals 11,600. After we condensed that down a bit, we had x plus 2y equals 11,480. So that would be our first new equation.
So to find our new second equation, we use substitution on the second and third equations. So we got 2x equals y plus 120, and when we shortened it down, it was 2x minus 2y equals 120, and that's our new equation. To find our variable, we decide to find x. So our 2 new equations, they were already opposite of each other with the y's. There was 2y and negative 2y. So we set them up and did elimination. And when we got rid of the y's, we got 3x equals 11,600. And so x would equal 3,866.6 repeating.
To find y, we plugged x into our new equation number 1 and solved. And to find z, we plugged x and y into our first equation and solved. For our answers, we got $3,866.67 in savings, $3,806.67 in stock, and $3,926.67 in mutual fund.
Alexander has $15 and wants to make the most of his money when buying pumpkins and squash for Halloween. He wants at most 4 altogether and at least 1 of each. Store A has 1 pound pumpkins and 3 pound squashes, and you can buy no more than 8 pounds of produce. Store B has 7 pound pumpkins and 5 pound squashes, and you can buy no more than 40 pounds of produce. The stores are selling the items for the same prices. Pumpkins are $4 and squashes are $3. Alexander is open to shop at both stores to find the best price. How many pumpkins and squash can he get under $15 while still getting 1 of each?
To make our linear programming model, we chose 4 random points and used those points to get the slope of each line. Our lines were y equals negative x plus 4, y equals negative 1/3 x plus 8/3, and y equals negative 7/5 plus x plus 8. We put all of the equations into standard form and got rid of the fractions by taking the equation times the denominator. To get greater than or equal to or less than or equal to, we plugged in 0 for x and y and solved.
The table down here is the exact same information from our equations, and we just copied it into a table to make it easier to see. So for our C equals, it's the cost of pumpkins and squash. So since pumpkins cost $4 and squashes cost $3, we did C equals 4x plus 3y.
Then you take the equations that we have already solved for and graph them. So x plus y is less than or equal to 4 would be graphed right here with a solid line. X plus 3y is less than or equal to 8 would be graphed right here, also with a solid line. 7x plus 5y is less than or equal to 40 is right here. And then since we cannot have negative pumpkins or squash, we have x is greater than or equal to 0 and y is greater than or equal to 0, which would be our x and y axes. So then after that, we have to plug in a point that is not on the line and figure out where our shading would be, which we found out would be in this region right here. And then we figured out our vertices. The first three were quite easy because they're all intercepts. That one's 0, 0. Then we have 4, 0, and 0 and 8/3. Then for this one, since it wasn't directly on any of the lines for us, we used elimination with the two equations of the line to find out that the last vertice was 2, 2. After that, we took the c equals and plugged in all of our vertices into that equation to find the best deal for the $15 that he had. So we found out that for $14 you could get 2 pumpkins and 2 squash.